Let's give this one a try as well. So we have here an aircraft is flying due north with the velocity of 200 meters per second. A side wind of velocity 50 meters per second is blowing due east. What is the aircraft's resultant velocity? Give the magnitude and the direction. So in this question, they want to say that first. Let's just be able to draw what is happening. So the airplane is here. It's a very bad drawing of an airplane. So we have an airplane and it is traveling north. It is traveling north. This is north, so we need to just make sure we always have our scale. If ever you're in an exam and you need to deal with north, south, east, west, it's best to just draw the compass on the side so you don't get confused. So it is flying due north with a speed of 200, or a velocity of 200 meters per second. Or you can, of course, if you like, you can write it like meters per second. Both is correct. This is the same as this. So, and at the same time, there is a velocity of 50 meters per second, or meters per second squared, as you like, of wind pushing the aircraft in this direction, to the right. There's a side wind. What is the aircraft's resultant velocity? This is the same as the previous question with the spider. What is the difference between speed and the distance or displacement when we're talking about the resultant? Resultant means the net. So this airplane is trying to fly front upwards or north at 200 meters per second, but the wind is not allowing it and it's pushing it to this side. So let us measure what is the resultant. This is the resultant. We can draw it like this. This is the resultant. So we can show, first of all, we use the Pythagoras theorem. We say a squared plus b squared is equal c squared. So let's do that. Let's say, so we know that this is our adjacent. Well, we can just make for ourselves, give us an angle theta here if we like. Here we have our adjacent. Here we have our opposite, and we need to find the hypotenuse. So we know the 200 squared plus 50 squared is equal to c squared. Bring this square on that side, so you have to square root. So it's going to be 200, it's 200 squared plus 50 squared, all under root. So first solve this part, then under root is equal to c. So just put it in your calculator and you will find what is going to be c. So I'm going to put it in my calculator as c right now. 200 squared plus 50 squared. The answer is 206.155 blah blah blah. This is the meters per second. So let's just say now we've got one part of the answer. We have this the velocity, but do we know we have the speed, but do we know the direction? The direction, give the magnitude as well as the direction. Now the direction of this is going to be in this direction, as you can see, because we drew it exactly like that. We showed that it is going north. The airplane is going from here. It's trying to go this way with this speed, and the speed of the wind is pushing it like this. So the direction it's traveling is like this. And if we look at our compass, it's actually going north and it's going east. It is in between. It is northeast. We can draw the line. It's going like this. So we can write here that the final answer is this much. Meters per second is the resultant speed in the direction of northeast, which is consistent because we had the wind going east and we were traveling north, and our final direction that it pushed us is northeast.